The ability to design models is one of the most important engineering skills. Therefore, when teaching math, we pay a lot of attention to teaching the students the skill of designing analogous problems. Those problems exemplify modeling in math. I would like to start my presentation by showing what Common Core curriculum says about analogous problems. Common Core provides guidelines in regards to teaching problem-solving skills and requires students to consider analogous problems. Particularly, it is mentioned that the students need to design the simpler forms of the original problems. We subdivide these simplified versions into three groups. The first group deals with numbers that are too abstract for human brain. When a problem contains numbers that are too big, too small, or highly precise, the brain frequently cannot make sense of the problem. Considering analogous problems with small positive integers helps to make sense of the problems. In science and engineering, there are two types of models that relate to the analogous problems of that group: size-changing models and details-cutting models. However, before prompting the students to use analogous problems for solving complex word problems, we provide several simple exercises. In this exercise, the students need to find the connection between their patterns and their models, and then identify the model's type. As you can see, the sizes of the models are comparable with the sizes of the original figures, but the models have much less details. So the answer is details cutting model. In this problem, the students have to get rid of parentheses without changing the numbers and their order. Since the numbers here are not palpable, all the numbers are too small and highly precise, an analogous problem involving size change and details cutting is needed. After calculating the result, we apply different variations and check for their correctness. As we can see, the second formula works. To add assurance, the students have to check the correctness using one more analogous problem. Since the formula involving double division works, we conclude that it might work for the original problem as well. The next group of analogous problems comprises of problems that involve variables. As you probably have already seen, the brain of some students gets frozen when the problems involve variables. It happens because each variable stands for multiple numbers, and it is not always easy to make sense of it. Looking at variable is similar to looking at a crowd and trying to understand the behavior of all the people as that of one body. When dealing with huge number of people, the statistics uses sampling. And we can try to use a similar approach when dealing with variables. Sampling means that the behavior of relatively small groups of people is studied and the results are applied toward all population. Sampling in case of variables would mean that the variables will be substituted by small positive numbers that represent some instances of the variables. Studying behavior of the numbers can show us the patterns that can be applied toward the initial problems involving variables. Below, we will present problems where sampling will help us better understand some formulas. The questions below are the typical questions that arise during math lessons when the students mix up 2 times x and x squared, distributive property with associative, and so on. Incorrect usage of distributive property would be prevented if the students were used to check their work using analogous problems. As you can see, putting small positive integers instead of variables magically helps in examining the correctness of the expressions presented here. The sample taking can be used in order to make sense of problems that contain long sequences of givens. For example, if one needs to calculate the sum containing 999 numbers, it is not simple to find the patterns that can be used in the calculations. However, using sampling and designing an analogous problem with lesser number of entries helps a lot. Here is an example that contains a sequence. There are 50 consecutive numbers where the first number is -25. The students need to find the sum and the product of the numbers. In this problem, as a rule, the students provide at first incorrect answer and without using analogous problem cannot find what is incorrect. Accurately designed analogous problem with just 6 numbers dramatically simplifies solution. The sum and the product in the analogous problem can be easily found. Looking at the sum, one can see that one of the numbers is not compensated. Looking at the product, one can see that one of the factors is 0. These two findings are to be applied towards solving a regional problem. In the original problem, the sum is -25 and the product is 0. After teaching the students in a very explicit way how to design analogous problems, we provide ample practice. The combination of explicit teaching and active learning with incremental scaffolding results in a steady progress of the students with different learning styles and the various levels of cognition. You are welcome to contact us at vk@vikaschool.com to learn more about our educational approach. Thank you.